Well, it's finally time to put everything we've learned about Newton's laws and forces and all that stuff and actually work out some real world problems. First problem reads, a 5 kilogram block is sliding on a surface where mu equals 0.4, I'll tell you about that in a second, at 6 meters per second. How far does it go before the block stops? Now this mu thing is talking about friction. This is called the friction coefficient, and it describes how slippery a surface is. And the formula for friction is very simple. It's just force of friction equals the coefficient times the normal force. I call it the fun formula because you've got F equals mu, and so it looks kind of fun. But that's how we're going to calculate the force of friction to see how quickly this thing's slowing down. So the first step in all of these problems is always going to be to draw a force diagram. So let me take care of that for you. Now the force of gravity is going to be 50 newtons because it's a 5 kilogram object, so you just multiply that by 10, or 9.8, whatever you're comfortable with. And for the normal force, we're also going to get 50 newtons because we know the object doesn't accelerate up or down, it's simply accelerating backwards. Next, we got to calculate the force of friction. If I apply this simple formula and I use the friction coefficient along with the normal force, I get a force of friction of 20 newtons going backwards, opposing the direction of the object's motion. So force of friction equals 20 newtons. And if I look at this force diagram, I can see that the forces are not balanced. They're balanced in the up and down direction, but they're imbalanced in the left and right direction, which means this thing has a net force of 20. Once I know the net force, I can just apply Newton's second law, which is F net equals ma. So 20 equals 5, that's the mass of the object, times a. And for acceleration, I get, make that 4 meters per second per second. And some teachers would write this as negative 4 meters per second to show that the acceleration is to the left. I don't like using negatives. I would rather just keep track of the fact that it's to the left. But if you want to put a negative to show that it's to the left, that's fine too, whatever you're comfortable with. But the question didn't just ask what the acceleration was. It wanted to find out how far the block goes before it stops. It's looking for delta x. Not a problem. We've played this game before. We just have to throw down our 5 variables of awesomeness to see if we can figure out what delta x is. And we know that the starting velocity was 6, the final velocity was 0 because it came to a stop. And we know that acceleration is minus 4 because it's accelerating at 4 in the direction opposite of where it was moving. So these two have to agree with a positive 6 and a minus 4. By running the formula, I got that the block went 4.5 meters before it came to a complete stop based on this acceleration and just using this formula. Here's another way you could have done it. This is if you're feeling kind of slick. If you started at a velocity of 6 and finished at a velocity of 0, then your average velocity was 3 meters per second. Also, to solve for time, if you started at the velocity of 6 and you finished at 0, and you got 4 slower every second, then it took 1.5 seconds for you to lose all of your velocity, right? If you were going at 6 and you lost 4 every second. So put these two together. You went an average of 3 meters every second for 1.5 seconds, then your delta x equals 4.5, just like what we had before. So to recap, here's the process on most of the problems that we're going to do. You start out by drawing a force diagram. You always have force of gravity and see if there are any other forces going on. If you want to, you can actually draw the block on the table. Sometimes that'll help if the problem's complicated. Sometimes on an easy one, I just skip drawing the actual problem. But you want to draw the force diagram, calculate all the forces that you can. If the forces are in balance, then the object goes at a constant velocity. In this case, they were not in balance, so we found the net force. The net force was 20 newtons. And then you use Newton's second law, F net equals ma, to find out what acceleration is. And once you know what acceleration is, then we're right back to the kind of problems we were doing about 10 videos ago, where you're just filling out your variables of awesomeness to find the information that they were looking for in the problem. Almost every force problem is going to follow this basic recipe of how to get through it. You just got to make sure that you've mastered the old steps and that you're comfortable with the new ones with drawing these force diagrams.